In episode 1, we understood what MCP is at a high level. In this episode, we go one layer deeper. What messages actually travel between the host, the client, and the server? What format are they in? How does the client discover what tools a server has? How does the model decide which tool to call? Understanding this architecture means you will never be confused by a protocol error when building your own servers. Here is the full message flow. The user types a question into the host. The host sends it to the language model along with a list of available tools from all connected servers. The model reads the tool definitions, decides one is needed, and returns a tool call object rather than a text answer. The host passes that to the MCP client. The client sends it to the right server. The server runs the function and returns the result. The result gets added to the conversation, and the model generates a final answer using the new information. Every message in MCP is a JSON-RPC 2.0 object. A request has 4 fields: the JSON-RPC version string, a numeric ID that matches requests to responses, a method name like tool/call, and a params object with the arguments. A response has the same ID and either a result field on success or an error field on failure. Notifications are like requests with no ID because no response is expected. This format is simple, human-readable, and easy to inspect with any JSON tool. MCP supports 2 transport types. The standard input-output transport is the simplest. The client launches the server as a child process and communicates over standard input and output. No network, no ports, no configuration. This is what Claude Desktop uses for local servers. The HTTP with SSE transport runs the server as a standalone HTTP service. The client sends requests as HTTP post calls, and the server pushes responses as server-sent events. This transport is required when the server runs on a remote machine or in the cloud. Every MCP connection follows the same lifecycle. The client sends an initialize request declaring its protocol version and capabilities. The server responds with its own version and capabilities. The client sends an initialize notification to confirm the handshake is complete. The client then calls tools/list to discover what tools the server exposes. From that point, normal operation begins, and tool calls can flow freely. Either side can close the connection cleanly at any time. Tool discovery happens immediately after the handshake. The client sends tools/list. The server responds with an array of tool definitions. Each tool has a name, a human-readable description, and an input schema that is a JSON schema object describing what arguments the tool accepts. The host injects all these definitions into the language model system prompt. The model reads the descriptions to decide which tool is relevant. This means writing a precise, accurate description is the single most important thing you do when building an MCP server. When the model decides to call a tool, it returns a structured object with the tool name and arguments. The host passes this to the client as a tool/call request. The client routes it to the server that owns that tool. The server validates the arguments against the input schema, runs the function, and returns a content array. Each item has a type and a value. Text results use type text. Images use type image. The result gets added to the conversation, so the model reads it and generates its final answer. Capability negotiation happens during the initialize handshake. The server declares which capabilities it supports from the set of tools, resources, prompts, and logging. The client declares its own capabilities, including whether it supports sampling, which allows the server to request language model generations. A client that sees a server declaring no resources capability simply skips sending resources/list. This allows older clients to work with newer servers without crashing. When you build a server, you declare exactly which capabilities it exposes. You now understand the full MCP architecture. JSON-RPC messages over standard input-output, or HTTP, the initialize handshake and capability negotiation, tool discovery via tools/list, and the full tool call flow from model decision to server execution and back. In the next episode, we write our first MCP server in Python, register a tool, and test it with a real client. Subscribe so you do not miss it. See you in the next one.